Detroit, Michigan. At a General Motors transmission plant, sparks from a welder's torch ignited flammable liquids in a conveyor drip pan. Fire raged through the factory. 6 people were killed, many more injured, and $50 million in property was lost. Texas City, Texas. At a shipping complex, a spark from a cigarette ignited ammonia nitrate fertilizer. An explosion ripped through the complex, setting off a chain reaction of devastating proportion. In the aftermath, 468 people lost their lives, 3,000 were injured, and $400 million of property was destroyed. Amazing, isn't it? How a single spark or a single thoughtless act could touch off such destruction and injury. The tragedies that you have just watched involve flammable liquids and chemicals, materials that when ignited can result in violent, devastating fires. I'm Mike Brooks, supervisor of the Plant Protection Department at Warrick Operations. As an operating, maintenance, or construction worker at this plant, you may be assigned to jobs in areas where there are flammable or combustible liquids. By themselves, these liquids are not dangerous, but if misused or improperly handled, flammable and combustible liquids pose very serious and possibly deadly risks. So when working in areas with flammable hazards, there's absolutely no room for error. The purpose of this presentation is to acquaint you with the safety precautions and procedures that must be observed in the presence of flammable and combustible liquids. We'll learn how these liquids ignite and how to prevent that ignition. We'll take a look at 2 of the areas where flammable liquids are used: the mixing room, which is housed in Building 847, and the coating lines, which are housed in Building 826. We'll also look at the types of operating, maintenance, and construction jobs performed in those areas. We'll discuss what to do in the event of a fire, and we'll look at the protection systems designed to safeguard property and, more importantly, your well-being. For your safety and that of your coworkers, it's vital to understand the characteristics of flammable and combustible liquids and why they pose such serious risks. First of all, flammable and combustible liquids by themselves don't burn. What does burn are the vapors they give off. The vapors of these liquids will ignite at a certain temperature, a temperature called the flash point. The flash point of a liquid is the temperature at which a liquid gives off sufficient vapors to ignite, either by spark, flame, or other ignition source. All flammable and combustible liquids have different flash points. Take diesel fuel, for example. Diesel fuel has a flash point of approximately 125 degrees. Combustible liquids like this have to be heated or vaporized to ignite. As you can see, by heating the liquid to a temperature above its flash point, it vaporizes sufficiently to burn. Liquids with low flash points can easily ignite at low temperatures. Gasoline, for example, has a flash point of -45 degrees. It ignites easily in the presence of any ignition source. The flammable liquids used in the mixing room, Building 847, and on the coating lines in Building 826 have low flash points that are below 100 degrees. Methyl ethyl ketone, or MEK, for example, has a flash point of 17 degrees, making it extremely flammable. This flammable liquid continuously gives off vapors that could readily ignite. The difference between flammable liquids and combustible liquids concerns their flash point. Liquids with flash points above 100 degrees are classified as combustible liquids. Liquids with flash points under 100 degrees are classified as flammable liquids. containers are labeled so that you know immediately which ones contain flammable liquids. For a fire to start, 3 agents must typically be present: fuel in its vaporized state, an oxidizing agent such as oxygen to support combustion, and a heat source to provide ignition. When all 3 agents come together in the right amounts and under the right conditions, a chemical chain reaction begins. The fire starts. This assembly of elements is called a fire tetrahedron. Of the elements in the fire tetrahedron, the heat source is most easily controlled. Heat sources include sparks from welding and burning, operations that generate friction, smoking materials, sparks from electrical equipment, static sparks, or open flames. In most cases, without a heat source, there will be no fire, unless, of course, the material is heated above its ignition temperature. That's why precautions must be taken to control and eliminate heat sources in areas where flammable liquids are used or stored. In operations related to the coil coating lines, you'll find flammable liquids in 3 areas: in the outside storage pads, in the mixing room in Building 847, and at the coater heads of the coil coating lines in Building 826. The flammable liquids used at Warrick Operations are transported to the plant by truck and stored in containers and underground tanks. As these signs warn, smoking or open flames aren't allowed here. In addition, this area is restricted unless you're authorized to be here. You may be assigned to do work in the mixing room. Let's take a look inside. This is Greg Barnett, finishing unit supervisor. Greg, could you tell me what's happening in here?
Mike, this is where the coatings are mixed for use on the coating line. The quantity and the amount of coating that we mix makes it one of the most hazardous areas of the plant.
That's why the environment has been engineered for fire prevention. Everything here is explosion-proof, from the floor to the telephones. The 2 forklifts are explosion-proof as well. An explosion-proof air makeup unit keeps the area ventilated by drawing vapors away and discharging them safely outside. An automatic sprinkler system has been installed to control fires and to cool the building in case of fire. Within a 50-foot area, you'll find plenty of portable fire extinguishers, too. All around the building are pull stations to notify the plant fire department in the event of a fire. The next area you need to be familiar with is Building 826, which houses the coil coating lines. Located in Warrick's finishing department, these production lines apply the coatings and solvents to the aluminum can sheet. Circulating through a closed-loop system, the coatings and solvents are piped to the equipment from the outside storage tanks and applied here at the coater head. Operating personnel in this area have a number of responsibilities. They transfer coils, level the metal to help ensure flatness, clean the metal, and acid treat it. Using the state-of-the-art equipment, they coat the sheets and then prepare the coils for packaging in the pack ship department. In addition to operating crews, construction and maintenance crews also frequently work on the coil coating lines and the associated areas. This is Leonard Mitchell, Alcoa construction inspector. Leonard, what type of work would a maintenance or a construction crew typically perform on the line?
Many types of projects, Mike. Sheet metal work, cleaning, structural work, piping modifications, and electrical work.
What type of work is this crew performing?
These people are performing structural modifications to the rinse tanks.
As part of an operating, maintenance, or construction crew, you have to be familiar with the safe procedures for working around flammable liquids. Before entering this area, for example, you should first check with the production people responsible for the lines. Find out what the state of the line is. Are there any containers of open flammables? Have they been removed, or has there been a spill in the area? Certain types of jobs will require additional personal protective equipment. If you're working with solvents in a cleaning operation, for example, you'll need face shields and rubber gloves. Each situation is different. Check with your supervisor or construction inspector to find out what personal protective equipment you need for the job. Areas containing open flammables are barricaded because they pose the greatest hazard. Remember, open flammables like these are giving off vapors in the presence of oxygen. These vapors could easily burn. All they need is an ignition source. Care must be taken to eliminate ignition sources within these boundaries. At Warrick Operations, we refer to operations that can provide an ignition source as hot work. Put simply, hot work means any spark or flame-producing operation. Here are a few examples. Welding, including thermite and CAD welding, cutting with an open flame, soldering with an open flame, open flames including smoking materials, matches and lighters, fuel-fired heating operations, grinding, percussion tools that generate sparks, sparking electrical tools, the operation of electric scooters or vehicles with internal combustion engines. Hot work is prohibited near flammable hazards, unless the area has been cleared of those hazards. To perform any type of hot work, you must first obtain a permit issued by the supervisor of the job, co-signed by the Plant Protection Department, and then approved by a production supervisor. When working near flammable hazards, you must take certain precautions to eliminate ignition sources. Use only non-sparking tools. For example, vehicles, like electric scooters, are not allowed unless special precautions are taken, such as obtaining a permit. No smoking or open flames are allowed, and no cutting or welding should be performed within the barricaded area. Outside the hazardous areas, you can use normal maintenance and construction procedures. Eliminating ignition sources is the most important precaution you can take, but knowing how to detect hazards is important also. Early detection prevents injuries and property loss. Most hazards can be detected by sight and should be reported immediately. But some hazards cannot be seen, such as flammable concentrations of vapors. Vapors from the liquids that we use are heavier than air, with a tendency to settle in low-lying areas or collect in confined spaces. The accumulation of vapors creates extremely hazardous conditions, as the following demonstration shows. Gas is placed inside a gas explosion chamber and allowed to accumulate. When the vapors build up and reach a certain concentration, they can explode. One way to detect vapors is with this device, called a combustible gas indicator. It monitors for flammable concentrations of vapors. Mike, how would you use this device?
You should monitor the air at low levels where vapors might accumulate. If this alarm sounds, you must evacuate the area immediately. Then notify your supervisor, others working in the area, and the Plant Protection Department.
Another important device is the portable ventilator, found in your confined space entry kit. It's useful for dispersing vapors in confined spaces. But to prevent possible ignition, be careful not to plug it in while working in the high hazard area. The plug is not explosion proof. Only the fan is explosion proof. One more point about flammable vapors. They have the ability to travel long distances sight unseen. Where vapors ignite, the flames flash back to the liquid, causing a rapidly spreading, hard-to-control fire. If you're ever in doubt that a flammable hazard exists, contact your supervisor immediately. For your safety, protection systems are in place to warn you and to extinguish fires. The coater heads, for example, are equipped with heat detectors. These sense heat and automatically activate the carbon dioxide system, which extinguishes the fire. When the system is activated, you'll hear this sound. That's the pre-discharge alarm and your signal to evacuate the area immediately. You will have 30 seconds to evacuate before the system discharges. designated evacuation routes are the two main aisles going east and west, or behind the lines going north through this door. If you see a fire in the area, you can manually activate the CO2 system. To activate the system, flip this switch. It's located on the wall directly across from the coder. After flipping the switch, evacuate at once. Get to a phone immediately and call the fire department at its emergency number 4333. Telephones are located throughout the area. While the CO2 system has the ability to put out fire, it can also be dangerous, causing asphyxiation, even death. If you're working in the basement or underneath the equipment or in the trenches surrounding the equipment, waste no time in evacuating once the pre-discharge alarm goes off. Don't wait for the CO2 system to discharge. For putting out small fires, carbon dioxide and dry chemical portable fire extinguishers are located on either side of the line. In addition, fire hoses and larger wheeled extinguisher units are available for your use. If a person's clothes were to catch on fire, fire blankets are located near the coder heads. Simply wrap the person in the blanket and then roll. We've just looked at how flammable liquids are used in certain production processes at Warrick Operations and why those liquids present hazards. As long as you understand those hazards and work safely, these areas are safe for you and your coworkers. Stay safe by following these procedures. Understand the conditions which vapors can ignite. Know where flammable hazards exist. Wear the proper personal protective equipment. Control and eliminate ignition sources. Know how to detect flammable hazards. Learn how to activate the fire protection systems. And be familiar with the evacuation routes in case of a fire. In the event of a fire, call the Plant Protection Department at 4333. The more you know about flammable liquids, the more cautious and alert you are, the safer you'll be. So take the responsibility for safe work habits. Do it for yourself, for your coworker, and for your family. Remember, with flammable liquids, there's no room for error.